Our sun and other stars are burning balls of gases. That's right. Here we go. The hydrogen in the center, the hydrogen for our very average star. Don't tell him. He's very average. He's like a C- student. Yeah. And it's a yellow star. It has this hydrogen in the middle, and these hydrogens fuse. So we have nuclear fusion going on. The two H's fuse to become helium. You can argue with your math teacher. H and H, 1 plus 1 does not equal 2. It actually equals 1 plus 1 equals 2 point something, something, something. That electron is kicked off. Learn about that with E equals mc squared. We'll talk about that later. But this is nuclear fusion in the sun. This is beautiful artwork. Here we go. Haley Rigdon. Awesome project. Here we go. She talked about the parts of the sun. We have the core. The core is where this nuclear fusion is taking place. In the core. Radiation zone because of the nuclear radiation. Convection zone. Let's talk about convection. Convection is where you have heat rising. Convection, heat rises. And then these particles that are spread apart, they rise, they convect, and then when they cool down, they come back down. So these particles are together. Kind of like the milk lady, convection. She goes uptown, she delivers the milk, she has a lighter load, she comes back down. Alrighty? Remember, our sun is a C-. It's a very yellow star. It's about 6,000 degrees plus or minus. And let's take a look at some stuff that comes off the outer edge of the star. This is a flare. A flare comes off, a flare comes straight out. This is a prominence. Prominence. Think of prom. Prom is where you go through that bubble thing, the bubble loop. Prominence. You take your prom date or you go stag to the prom and you go through the prominence. Prominence. Another flare kicks out. Flare. Our Earth compared to the sun. It is humongous. Yes. A flare getting kicked off. And to close,